In this video walkthrough, we're going to deploy an application to Kubernetes while making use of Kong's Kubernetes Ingress controller. Our application consists of 3 Docker containers, an Nginx web server, a PostgreSQL database, and a Redis key value store. We'll use Kong's Ingress controller to manage external access to our application services, and then we'll integrate a few plugins as well. We'll be deploying our application to Kubernetes by using the Google Kubernetes Engine, GKE. If you want to come alongside us on this walkthrough, you will need a Google Cloud Services account, and you'll also need kubectl and the Google Cloud SDK installed on your local machine. For our first step, we'll create a GKE cluster, navigate to the Google Cloud Console, and then create a new project. Choose a name for your project. Working within that project, navigate to Kubernetes Engine, and then to Clusters. Click on Enable to use GKE with your project. This will take a few moments, so we'll speed up the video to skip this part. After that starts up, you'll find yourself on the Kubernetes Clusters page. Click on Create. For our cluster, choose to configure a standard cluster. Set a name for your cluster and choose a region. Then, in the left menu part, find Node Pools and click on Default Pool. For the node pool, set the size to 1, giving us 1 node per zone, for 3 nodes total across the 3 zones in our region. We don't need more than this since we're just demonstrating a mini project. Click on Create at the bottom of the page. Creating a cluster takes a few minutes, so we'll speed ahead for this part of the video. Now that our GKE cluster has been created, we want to set up access to our cluster through kubectl on our local machine. To do this, we need to run gcloud init. This is going to walk us through logging in to our Google Cloud account. Then we choose our Google Cloud project. For configuring a default compute region and zone, we'll just choose No. Next, we want to set up a kubeconfig entry so that we can run our kubectl commands against our GKE cluster. For this step, we run gcloud container clusters get-credentials, and then the name of our cluster, my application, and then we're going to add an argument for region, which is the region we set for our cluster, US Central 1. First, we need to write a deployment manifest, which outlines what containers make up the application that we'll deploy. We'll open a file called deployment.yml. We set the API version, along with the initial information. We'll give the name my app to our deployment. And we'll set replicas to 1. And then we'll write out the spec with our 3 containers. Our first container, which we'll call server, will be our Nginx web server, which is accessible at the container's port 80. Next, we'll have our Postgres container. We make sure to add the environment variable for setting a password for this database. The setting of this environment variable for password protection is noted as part of the documentation for using a Postgres Docker image. The database is accessible at this container's port 5432. Lastly, we'll have our Redis container. Redis is accessible at this container's port 6379, and per the instructions for how to set an access password, we need to add a startup command for this Redis server, along with a command line argument for setting the password on the fly. After we save our deployment file, we apply it with the command kubectl, that's kubectl, apply -f, and then the name of our file, deployment.yml. We can run a command to verify that our deployment is up. We run kubectl get deployment my app, and we see that it's not ready or available. But after a few moments, we can run that command again, and this time we see that it is ready. 1 out of 1, it is available. Next, we can run kubectl get pods to see the name of our pod that's running, and there it is. And with that pod name, we can look at the logs for each of the 3 containers in the pod. We call kubectl logs, then the name of our pod, followed by the name of our container. We gave server for 1, and there's a log for the Nginx server. We can run that again with the name of our container, Postgres, and there's the startup log for our Postgres container. And lastly, we use the name Redis, and there we see the log for our Redis container. It looks like our deployment is up and running. Next, we need to configure a service so that the ports on our cluster's containers are accessible from outside that pod. We write a file called service.yml. We set the API version, and we give our service a name. Then we set the ports. We'll use the same port numbers for our pod as the target port number on the container, just to make it easy to remember. So we set our pod's port 80 to bind to the server container's port 80. Similarly, we bind the pod's port 5432 to the Postgres container's 5432 using TCP, and we bind the pod's port 6379 to the Redis container's port 6379, again using TCP. And then we save our service.yml file. And we apply the service manifest with kubectl apply -f service.yml. After a few moments, we can run kubectl describe service and the name of our service, my app, and this shows us how ports bind to each of the container's ports. Next, we want to deploy the Kong Ingress controller. But before we can do that, there's an additional step we need to take since we're using GKE. There are some unique admin permissions related hurdles when using GKE, and Kong's documentation on the Kong Ingress controller tells us that we need to create a cluster role binding in order to have the permissions to make some of the GKE cluster configurations that we're about to make. So we'll create another file called GKE rolebinding.yml, and really the code for this file comes to us from Kong's documentation. This manifest is for a cluster role binding. We will add a role ref, which is a cluster role. And we'll add a subject, which is a user. For the subject name, we will need our Google Cloud account email address, and then the namespace, kubesystem. We save that GKE role binding file, and we apply it with kubectl apply -f and the name of that file. Next, we can deploy the Kong Ingress controller. Fortunately, Kong has already written out the entire manifest for deploying the controller, and that file is accessible at bit.ly. So we just run kubectl apply -f https bit.ly/k4kas. That's Kong for Kubernetes, which is nice and easy to remember. After we run this command, we can check for the service status by running kubectl get service -n for the namespace, Kong. If you do this right away, you might see that external IP is pending. The Kong Ingress controller service is still starting up. No worries. Just wait a few more moments, run the command again, and you'll soon see that you have an external IP. Next, we're going to set an environment variable proxy IP, essentially pointing to that external IP. This will make it easier for us to quickly send requests to that IP address. The command to set this environment variable is a little bit long, so you might just want to pause the video just so you can look at it. After that, we can echo our proxy IP to see it. And there it is. And we can even send a curl request to that proxy IP just to see if we can hit that server. And there, we can see that we're hitting the Kong proxy. We get a message back that no route matched with those values. And that makes sense because we haven't configured our Kong proxy to do proper request routing yet. Now that our Kong Ingress controller has been deployed, we need to configure it to route requests from the outside world to specific services and ports within our GKE cluster. First, we'll handle the basic HTTP requests that are intended to hit our web server. We open a new manifest file called http ingress.yml. In this file, we add annotations to our ingress. We add Kong's strip path annotation, and we set our Ingress controller to use Kong. For our HTTP rules, we want to route requests to our Kong proxy's root path / to our backend service named MyApp. We want to route to that service's port 80. You'll recall from our service manifest that requests to port 80 on our pod will get routed to our pod's port 80, which is our Nginx web server. We save the HTTP Ingress manifest and then apply it. Now, when we perform a curl request to our proxy IP, which by default goes to port 80, we get a response from the Nginx web server. We similarly want to connect to our Postgres database and our Redis store. These connections require us to configure the Kong proxy to listen for TCP traffic on specific ports. We originally applied the pre-configured manifest from Kong that was referenced at bit.ly. Here, we want to patch that deployment by adding a few more things of our own. Let's open a manifest file called patchkongdeployment.yml. For the proxy container, we want to add a new environment variable called kongstreamListen and give it 2 addresses and ports to listen on. We want it to listen on port 11111 and port 22222. We'll use 11111 for Postgres connections and 22222 for Redis connections. We add the environment variables and the port configurations, and then we save our file. Similarly, we need to patch the service related to the Kong Ingress controller. We'll create a file called patchkongservice.yml. We want our Kong proxy to listen on port 11111 for TCP traffic, and then route that TCP traffic to the Kong Ingress controller for handling. We do the same for port 22222. Next, we apply the 2 patches that we just wrote. First, we patch a deployment in the Kong namespace, patching our Ingress Kong deployment according to our file at patchkongdeployment.yml. After that, we will patch a service in the Kong namespace, patching our Kong proxy service according to the patch file located at patchkongservice.yml. Now, we'll further configure our Kong Ingress controller with a TCP Ingress manifest. Create a new file called tcpingress.yml. We'll set the name and the annotations. And then we'll set some TCP rules. Requests arriving to Kong at port 11111 need to be routed to our backend service, MyApp, at port 5432. That will go to the Postgres port on our pod. Requests arriving to Kong at port 22222 need to be routed to the backend's port 6379. That's our Redis port. Then, we apply the TCP Ingress manifest. Now, let's test that our TCP Ingress configurations work. On our local machine, we run the PSQL client. Our host is at our Kong proxy IP, and we're going to port 11111. The username for our Postgres deployment is Postgres. We're prompted for a password, which we had set way back when we wrote our deployment.yml manifest file. And we're connected. Let's exit that. And similarly, we'll connect to Redis. We use the Redis CLI application, set the host to our proxy IP, and the port is 22222. And for Redis, we set the password at the command line. And we're connected. Now that our Kong Ingress controller is working and configured, let's add in the use of Cert Manager so that we can access our Nginx web server with HTTPS. For this, we'll follow the steps outlined on the Kubernetes documentation page for using Cert Manager. First, we apply the manifest that deploys the Cert Manager. We use kubectl apply-f, and then we reference the latest Cert Manager manifest in the repository on GitHub. After that, we can check the pods in the Cert Manager namespace. We use kubectl get pods and the argument for namespace Cert Manager. Next, we'll need to add a DNS record for a domain that we control. We'll be using this domain to request an SSL certificate through Cert Manager and Let's Encrypt. I have a domain, codingplus.coffee, which I'll add some records to. Here we want to add an A record, pointing a subdomain to our proxy IP address. After some propagation time, we should be able to ping our subdomain, and it should get us to our proxy IP address. Now, we need to modify our original HTTP Ingress YML file to use our newly configured hostname. We add a single line under our rules, setting host to our configured subdomain. We save the file, and then we apply it. Now, when we send a curl request to the full hostname instead of our proxy IP, we see the response from our Nginx web server. With our domain name routing properly, we need to request our SSL certificate. First, through Cert Manager, we need to create a clusterissuer.yml file. Here, we're creating a cluster issuer resource, configuring it to use Let's Encrypt. We're going to go through Kong's Ingress controller to facilitate this certificate request. We save the file and we apply it. Now, we need to update our HTTP Ingress YML file further so that it provisions a certificate and uses it. We open up that file and we add 2 lines to our annotations, which tell the Ingress controller deployment about how Let's Encrypt will be used for certificate provisioning. Then, in the Ingress spec, we add TLS along with a secret name and our host, which is the domain name that we have set up. We save the HTTP Ingress file and we apply it. We can call kubectl get certificates to see when our certificate is ready. Once ready is true, our certificate has been provisioned and we should be ready to go. Now we can send a curl request using HTTPS, and it works. Next, we'll configure the Ingress controller to use Kong's HTTP log plugin. This logs requests and responses to a separate HTTP server. We're going to use mockbin for this, which gives us an endpoint where we can tell our HTTP log plugin to send its data. At mockbin, we'll create a new bin. Then we end up with a unique URL for our bin. We're going to copy that. Then for plugins, we first create a plugin resource. Let's open a file called http://logplugin.yml. This is a Kong plugin. We choose a name for our plugin resource. We'll call it http log plugin. And which plugin is this specifically? It's the http log plugin. For configuration for this kind of plugin, we need to specify the endpoint where request and response info should be sent. For this HTTP endpoint, we'll paste in that mockbin URL that we just had, and our method will be post. We save that file, apply the manifest, and our plugin resource has been created. Now, we update our http ingress.yml manifest again, adding a single line for using Kong plugins. Here we use the name of the plugin resource that we chose in our previous manifest file, that is http log plugin. We save the Ingress YML file and we apply it. Next, we'll use curl to send a basic request to our domain. Then we open up the request history for our mockbin, and there we see our request. The Kong HTTP log plugin has sent request and response info from that last curl request over to this third-party server. Last of all, we're going to add one more Kong plugin, the correlation ID plugin. This plugin appends a unique value, typically a UUID, to the headers for every request. First, we create the correlation ID plugin resource. Let's open a file called correlationidplugin.yml. This is a Kong plugin. We choose a name for our resource, namely correlation ID plugin. And which plugin is this? Specifically, it's Kong's correlation ID plugin. For plugin configurations, we want to specify the name of the header where the correlation ID should be written. We'll go with my unique ID. We'll choose UUID from among the possible ID generators available, and we will choose not to have this value echoed downstream. We save the plugin resource file and apply it, and this creates our plugin resource. Again, we update our http ingress.yml file. Now, in our list of Kong plugins under annotations, we add our plugin resource by referencing the name that we chose, which was correlation ID plugin. We save the file and apply the changes. Then we make another curl request to our domain. And again, we check the mockbin history for the latest request. This time, when we look closely at the headers in that request, we see a new header called My Unique ID. This comes to us from the Correlation ID plugin. It works. And that concludes our walkthrough for how to manage a Dockerized application in Kubernetes with Kong Ingress Controller. Don't forget to spin down your GKE cluster so that you don't start incurring costs. In this walkthrough, we took an application consisting of 3 Docker containers and deployed it with Kubernetes at GKE. Then we configured Kong Ingress Controller to do routing of HTTP requests to our Nginx web server container, and also routing of TCP connections to our Postgres and Redis containers. After that, we made use of Cert Manager so that we could provision an SSL certificate to handle HTTPS requests. Lastly, we integrated 2 Kong plugins, HTTP log and correlation ID, into the Kong Ingress controller. Thank you for joining us.